So we're going to graph quadratics today, and we're going to do it using tables, and this is not the way that we're going to ultimately end up doing it, but this is a nice way for us to see how this works. I'll show you some cheats and tricks for this, okay? But remember that quadratics follow a rule, okay? And that is that y equals ax squared plus bx plus c. And we've talked about this a little bit before. We've talked about the c value is like in linear. It moves the actual line on the graph up and down, so vertically. And then instead of having a gradient, you've got an a value now, and that controls how tight the pinch is on the curve. So the higher that number is, the tighter the pinch on the curve will be. But then you've got a b value now as well, which will shift the graphs left and right, okay? Now, you'll notice that the first example, when I get to this one, doesn't have a b value. So whatever happens here, this is going to end up reflecting around the y-axis, but we'll cover that in a bit more detail as we go. The first thing that I want you to do though, and this is more for next year than for this year, is have a look at the format of the way that the line or the equation is actually written. So this is in expanded form here. And if you, because this one's missing a b value, this thing's suddenly chucked a wobbly and doesn't want to move. Hang on. So if we have a look at something like this equation here, this is a good one. This one is in expanded form. So that's what the equation looks like if it's in expanded form. If we factorize that, so, you know, this is the one with the brackets, brackets, brackets. So this is factorizing trinomials like we've been doing. So my x's go in. Have a little look at this symbol here. It's a negative, so I know I've got a plus and a minus. Looking for factors of 8 that'll make 2. Let's try 4 minus 2. And so what I've got now, if I was doing null factor method, is the solution for the x-intercepts. But for today, this, if you see an expression written like this is in factorized form. So it's the same equation, it's just rewritten in a different way. And the last one is the very last questions in a really unusual format like this. This one is called turning point form, okay? Now, each of these different equations, the way that they're written, have got their merits, okay? If I take this turning point formula, for example, I can see immediately when I look at this what the turning point is. The turning point happens at -4, -9. So whatever happens with this curve, I know that it will turn at -4, -9. So that's going to be the point that this thing turns around and goes back in the other direction. The disadvantage of this is I can't see where it's going to cross the y-axis, and I can't see where it's going to cross the x-axis. If I have a look at it back here, my factorized form, so now I'm talking about this one here, I can see the 2 points where it's going to cross the x-axis. It's going to cross at -4 and +2, so it's going to come down through here and up through here. But the problem with this one is that I can't see the turning point and I can't see the y-intercept, okay? But if I was presented it in this format, I can see where it crosses the y-axis, which is actually scarily close. I got quite good there, at -8. But I can't see the x-intercept. So we need to be able to move between the three formats, mainly next year, not this year, so that you can find those points. So I'm only interested in a few things. Hit me. Yep.
Wouldn't, for the x crossover, wouldn't it be a +4 and -3?
No, because we use null factor law, okay? So I'm skipping ahead here, so you can see this on video later. I just automatically said, so by null factor law, my x's are going to be at -4 and +2, okay? So that's where those 2 points came from. We haven't really learnt that yet, so it's a good question. If we can move between particularly these two here, because there are other cheap and dirty methods for working out what the turning point is, if you can move between those two, you can plot these things without these ridiculous tables, okay? And ideally, if you can move it into turning point form, you can even find the turning point. But more often than not, if they give you a question next year, for example, that's in turning point form, this is a great situation because this one's really easy to turn into the other two. And then you can find all the info you need. And all you need to successfully plot one of these things, instead of having all the points on the line, is you just need to know where it crosses, bearing in mind that these are not the right spots. You need to know where it crosses the X's, where it crosses the Y, and where it turns. And once you've got those 4 dots, you just do a nice curve to join them together. Is that sounding okay to everyone? Going back to what we're going to do today, okay, and a couple of cheats methods, okay, for the test. When I look at these, unfortunately for you, I've seen these for 12 continuous years, so they just jump straight out at me, okay? But I note when I see this one, that this one does not have a B value, okay? It's got an A value of 1, it's got a C value of -9, but it doesn't have a B value. So immediately when I see this, I know that it's going to reflect about the Y axis, okay? So what I do when I start these, and I generally do this even if I think it's going to shift, is I start in the middle here at 0, okay? So I'm going to start solving this from here. And this is simple substitution, okay? So it is actually as simple as it looks. It says, if X is 0, what's Y? So you just sub 0 up into the equation and you go 0 squared is 0 and 0 minus 9 is -9. Then you go 1 squared is 1 and 1 minus 9 is -8. 2 squared is 4 and 4 minus 9 is -5. Everyone's seeing where I'm going with this? And then we go 3 squared is 9 and 9 minus 9 is nothing. That's nice. I've just found the x-intercept. And 4 squared is 16 and 16 minus 9 and yada, yada, yada. And we keep going, okay? Now, there's not much point in going much further than that because it's not going to fit on the graph, okay? But did you notice how I went through my positive numbers first? Yes, everybody? Notice that I went from 0 through to 4. I did that deliberately because I'm not going to go and put all of those negative numbers in, okay? I have got a image that rotates or copies itself, if you like, so I can just copy my answers over here and I'll be fine, okay? So I don't need to worry about filling in or putting them all into my calculator. Now, what I should do now is I should put all of those points on the plane. Okay, so again, what I'm going to do is I'm going to start back at 0 again. I'm going to go 0 minus 9 and put that dot in. 1 minus 8, 2 minus 5, 3, 0, and 4, 7, here like this. And remembering that each of these is a coordinate, right? So that's where x is 4, y is 7. So I'm just reading those as x, y coordinates. That's where I'm getting those from. And because it's a reflection, that means that I don't need to worry about finding the points. I'll just copy them over here. It's a bit faster and it's a little bit easier. And it's a bit of a dirty tactic. You can't use it all the time, but it definitely works with these ones that don't have B values. And then really importantly, do not use a ruler, okay? You need to freehand this. It's a curve. It's not a series of straight lines that connect dots. So we must go down and turn and come up. We accept that sometimes these do not turn out to be neat, okay? So don't worry if you're a bit dodgy at doing curves. The only other thing we need to do is make sure that we're labeling this and giving this an axis because we don't want to lose any cheap marks. We will label that X and Y if it's not on there already, and we're done. Now, one last thing. If you are doing this topic, and when you end up with a curve, you end up with something that looks like this, you have 100% stuffed up, okay? This is a cubic graph, and we're not doing cubics, we're doing quadratics, and quadratics are all smiley faces or sad faces, okay? So if your A value is positive, it's a smiley face, and if your A value is negative, it's a sad face, like this one down here, okay? This one will make a sad face. How are we going with this? Yeah. Okay, so if the B value has an X, we're in a bit more trouble, okay? So this one's wrong, okay? We know this one, oh no, this one's right. See, this one's got a b value of minus 10 and it's shifted to the right. So when we did this one, just to try and make this a little bit more kind of compact, rather than me talk for too long in this video, do you notice that this one's missing a c value? There's no c value on the end here, okay? So what that means is that it's 0, okay? So really what this is x squared minus 10x plus nothing, and that's why that big blue dot there, it passes down through the origin, okay? But what you'll need to do is I would still start at 0 myself, and then I would start shuffling along and trying to find where the other x-intercept is. The numbers, this is a good question. So hang on, before we lose it, because we're still, you'll have to listen to all of this later if you talk now. So Zara's good question, okay? Why doesn't that one reflect around the origin? It doesn't reflect around the origin because we've got a b value here, okay? So remember, as soon as there's a number as a b value, it's going to shift it left or right, okay? Now, if it's a negative b value, I think it shifts it right and vice versa, okay? But it's a bit hard to work out until you've seen a lot of these, how far it's going to shift, okay? Now, these tables, this is why this is a completely rubbish way of doing this, okay? And why we want to do this to get to the test and get through the fundamentals and then stop, because we could use null factor and we could do this quite easily, okay? Have a look at the original equation. Let's factorize that, okay? We can take x out the front of x minus 10, and if we make y equal nothing, by null factor, we know that the x value is going to be 0, and it's also going to be positive 10, okay? So that means that it's going to pass back up here, and then all we have to do is find the turning point, which I haven't taught you yet, and I won't do now, but we can easily solve this one. If we had those 3 points, we just dot to dot them, and our curve is drawn. Same sort of deal when we go down, so you'll see another one a little bit further down the page where you've got all 3 values, like this one here. We know that this one will shift to the left. It'll shift in a negative direction because we've got a b value of positive 2. I think that's enough information though. I've got to stop talking to you now because I'm starting to give you like 2 or 3 lessons in one go. So you need to just concentrate on filling out your tables today. The first few will reflect around the x-axis for you, and by that stage you guys will be far enough apart from one another that I can move around and help you with the others, okay? How's that sound?